Hey everyone, we're presenting Cabal. Next slide. So, brief agenda. I'll talk quickly in prose about what it is. Uma will give a demo. We'll talk about actually the why is after. So Uma will give a demo, talk about how it works, and then we'll talk about why and the bigger picture and sort of like what's next. So in brief, Cabal is just collab land, which is ETH activity gated Discord channels, but maintaining user privacy with zero knowledge proofs. And rather than talking too much about what that means, I'll let Uma give the demo. But the key thing is we're sort of like figuring out the last mile of actual ZK apps. A lot of our contribution was getting things working with MetaMask Snaps, which is this MetaMask plugin system. It should actually be usable today, and part of what we're showing today is an actual running Cabal instance for people who attended like private anonymous or private chat for people who attended DevCon 1 through 5. If you want to join and chat with other people from old DevCons, come see us later.
I'll just talk into this. Cool, yeah, so here's the demo. So as Lakshman mentioned, Cabal is basically, we set up this Devconnect Anon Edition Discord server so people from previous DevCons can chat anonymously. And we configured it, so we invited the Cabal bot to the server, which kind of manages the roles. To use the Cabal bot, you just type configure if you're the admin, and you put in the, I don't know if you guys can see super well, but you put in the Merkle root and the corresponding role you want, and then it'll register that. And then if you're a user, you go to the Cabal verify channel, you just type /verify with the Merkle root that you want to verify for, and it generates a link. So I already did that for the, I haven't actually been to any DevCon, so I made a root with just me and Lakshman as like a demo, and I generated a link for that. And so it gives you a link, and then you go to our website, and the website basically helps you generate the ZK proof that you submit to Cabal, and then Cabal will give you the corresponding Discord role. So here you can see I'm going to connect to MetaMask, and then I'm going to get my Merkle proof in the front end because I need to pass that in for the ZK proof. And then I'll click Generate Proof. And you can see that it's starting to run the snap. And so if you go to the settings of this MetaMask, oh no, you go to settings. So basically, Snap is kind of a way, we'll talk about this later in the architecture, but it's this secure enclave in MetaMask where we can compute stuff on your private key. And so the private key is an input into our circuit. And we'll also go into the circuit later, but it's running. And so hopefully it should be generating the proof. It takes a bit because the Wi-Fi here is like a bit slow. So while that's running, I'll kind of go back and talk about the circuit. So our circuit, at a high level, it's a pretty simple circuit using 0x Parks. Let me go back to slideshow mode. So 0x Park, some people at 0x Park released a ECDSA circuit to basically verify that you control a private key to a particular ETH address. So that's one component of our circuit. It's at GitHub. So your private input is the private key. You put it in the circuit, and then you get out your ETH address. And then the other part of the circuit, that template plugs into the Merkle tree verifier part of the circuit, and you have private inputs that are your Merkle path elements and your Merkle path indices, so the Merkle proof. And then there's a public output, which is the Merkle root. And then we also have a nullifier, so we take the private key and Poseidon hash it and get a public output of the nullifier. So that's the circuit. And then the architecture is we have this web client that basically you get your Merkle root and your Merkle proof from. And then you can imagine, let's check actually if our proof is done. Okay, so our proof is actually done. And so you can see we've generated the proof in browser. If you look at the network tab, you can see that I haven't done anything. I haven't sent any requests. And here's the proof. And then you can submit the proof. It goes to our server. It verifies the proof is legit. And then you're verified. So we'll go back to Discord. And now I'll have like this test server role. So that's kind of the end-to-end demo. But yeah, so that was like a pretty smooth experience, right? Where the user doesn't even really need to know what's like going on under the hood. It's super simple because they can just use MetaMask and basically generate the ZK proof and submit it to us. Kind of as a contrast, a local proving experience might look something like you get the Merkle root and the Merkle proof, and then you have to like get your private key, create an input.json, you download like the WASM and the Z key to run the circuit locally, you have to install Snark.js, you have to run it locally, you have to copy the proof back to the web client, and then you have to like do this whole thing. And we actually have a mode in our app to help people do that in case they don't want to use MetaMask Flask or like, you know, they want to run the local experience. But we think it's really important that it's easy for users to use. Yeah, contrasted with the MetaMask enclave proving experience using snaps, you can see that everything's just done in browser, and that was the demo. So it's like super simple for the user. And I think to our knowledge, we are the first people to actually generate a ZK proof in a MetaMask snap. So that was kind of our like big output and contribution of this project that we want to open source and make it easy for everyone to kind of use because it's such a smoother experience. And there's a couple tricks and hacks along the way, and there's still some things we're waiting to upstream into MetaMask. And obviously we want MetaMask Flask, which is the development version, to be upstream into main MetaMask. So yeah, there was a bunch of tricky engineering things there. And we're going to give a snap tutorial at our workshop/breakout session. So if people are interested in that, yeah, come through.
Cool. And I'll talk a little bit more about kind of the why and I think how we're thinking about the bigger context of what we're doing. So at a high level, I think we think that gating conversation on activity that people are doing in Ethereum is demonstrated to be kind of like an interesting primitive for conversation. Collabland, Guild.xyz, there are a few other projects that sort of like exist within this this context. But obviously, and you know, as a user of these things, doxing your address sucks, or you know, even showing that like one statement about you is linked to other statements about you sucks. So we wanted to kind of like explore, like, is it possible to do it in a way that where you reveal no information? And then finally, like, why did we go through all this work of like integrating snaps? Well, we think that browser wallets are realistically how people integrate with the internet, or interact with the internet rather. Like, there's a lot of like theoretical ideas about what we can do with zero knowledge proofs, but we really want to see how do we get it to that last step to like all the people who can use stuff today. And so hence the obsession with trying to get things working with MetaMask. So kind of like the bigger picture, and this is going to be a little kind of like high level and hand wavy, but we sort of think there's this kind of new primitive that, or this new way that people will engage online that is enabled by two things, basically these like blockchains existing and zero knowledge proofs existing. We call it credible pseudonymity. And it's based on kind of these two key observations. So one, this is like since I guess 2018, 2019, a lot of like interesting identifying information that people care about like just seems to be gathering on these credibly neutral ledgers, signed in some way kind of associated with public addresses that are kind of like attestable from private keys. But then the other thing is like people don't necessarily only act from their sort of like government issued identity online. There's a lot of pseudonymity on Twitter, for example, and various other platforms. And it seems to be like a non-trivial driver of future economic activity, just like pseudonymous speech and action. So this is, yeah, so I wanted to present like two kind of like, I think sometimes when we talk about identity and speech and stuff, like we don't think about like what things look like in a very internet native way, native to like public key cryptography rather than social security numbers. So I wanted to present two kind of crazy visions that are sort of motivating us for what the future of speech looks like. So one is you have all these kind of like ledgers like ETH where people are doing stuff, and every piece of activity or speech that someone makes, they can choose some arbitrary subset of past activity to associate with it. So it's like every single piece of activity or speech So like financial activity, tweets, whatever, that happens online in terms of how other people perceive you. You choose how you identify it with everything you've done in the past. So kind of crazy idea. Not going to go too much more into it, but just like as a really pie in the sky thought, it's an interesting thought experiment. And then the other is like if you really think what is pseudonymity in like the long term, like maybe it's just like this big, like kind of like hierarchical DAG structure where you have like groups of pseudonyms that point to other groups of pseudonyms. And maybe at the root, there's like some notion of like your actual identity, but it's like everyone is just speaking from like multiple of these pseudonyms. And one of the interesting thoughts here is why should this DAG not kind of like be enabled to grow infinitely? In some way, we're sort of like building the kind of like glue that creates these arrows. So I'll quickly talk about kind of like what I meant to convey here, but like let's say there's like some canonical identities to start with, then maybe people create pseudonyms that say like I am one of, or like some predicate identifying something about these, but like without revealing exactly what you are. And then you can have like new pseudonyms that refer to those pseudonyms and et cetera, and like random remixes of that. So why can't this DAG just grow forever? Why can't we have tools to just kind of like arbitrarily relate ourselves to other NIMs that exist online? It seems like ZKPs plus Ethereum can be the thing that helps that happen. So in terms of what's next, to get a little bit more tactical, we have a bunch of ideas. Some people here included like working on the stuff, Vivek's working on ZK Reddit, for example. A bunch of ideas to ship kind of like around these primitives for last mile of ZK that we've been developing. We think it's pretty important to actually put things out and like study user behavior. It's kind of this new thing we're dealing with, this credibly pseudonymous speech. We don't want to like theorize too much about the ideal protocol. We just want to ship stuff and like actually see how people interface and interact in these like weird new like environments we create. And then we want to like, kind of like more specifically to Cabal, we plan to generalize it. We want to make it so anyone can kind of like with one click create a Merkle root for some ETH activity and create a Discord server with private channels based on that. In terms of infra, there's also like a bunch of stuff we want to push on. Yi-Sun presented a ZK tester earlier. I don't know if he's here, but which was basically like you create zero knowledge proofs for an arbitrary thing in the Ethereum state root. So like obviously this is kind of like, this could be a perfect version of our backend, but there might be a whole spectrum of like things in between. Like right now we're very, what's the word I'm looking for? Our approach is very specific to like, it's like kind of static in a way, and like it would be nice to have things that are like self-updating. So we have a bunch of ideas for how to do that. Maybe in the future using ZK tester, maybe in between. We have some ideas for how we could like have self-updating accumulators on chain, which are basically indices of like interesting identifying information. We want to look in, we have some early ideas for mobile wallet stuff, but it's a little harder than browser wallet, but like that's definitely something we're thinking about. We want to look at all the Plonkish systems, of course, like as Halo 2 tooling gets to the next step, like we'll probably want to switch that in because plookup actually radically improves our proof generation. There are some interesting ideas at ZK Summit around remote proof delegation that we want to look into. And finally, a lot of standardization. We're touching new stuff, so it's like really important to sort of like make sure we're not repeating work collectively. And yeah, we'll be doing a breakout session from 2 to 4 today, kind of like just sort of like trying to figure out the future of all this stuff. So feel free to come by and we'll chat more. And then I just wanted to kind of like leave with one sort of like interesting provocative question. I think like we see these curves for like interesting proofs in the browser kind of like dropping really rapidly. Like 3 years ago, it was like unthinkable to do the fact that like Uma actually generated the proof she generated, which involved like ECSA operations in a web browser in like not days or something like that. It's like absolutely insane. And so I think it's interesting to project forward maybe another 3 years, and it's like what happens when those proofs take milliseconds to generate? Like what kind of crazy, like at what granularity will people be generating zero knowledge proofs with activity they're doing online? I think it's like interesting to think about and probably useful for thinking about what to build next. And that's it. Any questions?